Welcome to Probability and Statistics. In this lecture video 8.3, we're going to talk about how to estimate the population mean where the population standard deviation is unknown. Alright, so since a population standard deviation is unknown, what we're going to end up using is the sample standard deviation. Kind of weird because since I don't know my population standard deviation, what we can use is the sample standard deviation, which, as you can recall, is denoted as a lowercase s, right? And we can also use the t-value rather than the z-score to construct the confidence interval. So we're still trying to construct a confidence interval. So the difference between this video versus the 8.1 is now we're going to use the simple standard deviation and the t-value, since we do not know the population standard deviation. So the only thing different with the margin of error formula is rather than having a sigma here, we have a lowercase s. Rather than z sub alpha over 2, we're going to use the t-value. Okay. So when we use the t-value here, okay, this is very important. The area under the t distribution is going to be n-1 degree of the freedom. Okay, what we got to remember is when I do the t-value in the previous lecture video, whatever degree of freedom is, that's the number I'm looking up. But for the confidence interval, we need to go with n-1 degree of freedom. Alright, so this is how we do it by hand, just like with the lecture video 8.1. Okay, the only difference is, again, is rather than having critical value for the z, now we have a t sub alpha over 2, because confidence interval is really regarding to the two-tailed type of problem. What is in the middle? Okay, the confidence interval is what's in the middle. Alright, using sample standard deviation instead. Alright, so to do it in a calculator, this time rather than go to z interval, we're going to go to t interval. Okay, and the things we're going to type in is my point estimate, the sample standard deviation. So you got to watch that word very carefully. That's how you distinguish the difference between problem from 8.3 versus problem from section 8.1. Okay, now if I need to type in raw data into the calculator, okay, raw data, so then we got to type in our data under L1. okay, raw data, there's no L2, frequency one at a time, sea level. Because if I type in the raw data, the calculator automatically gonna compute the sample the point estimate and the sample standard deviation for me. So this is all I gotta type in. Alright, so let's give it a try. Okay, let's give it a try with some word problem here. A lot of these problems is divided into steps. Okay, so a geologist examining 22 water samples, okay, for magnesium concentration. The mean magnesium concentration of a sample data is 0.637. So the mean out of the 22 water sample is 0.637. Alright, cc per cubic meter with a standard deviation. Okay, so what does this standard deviation mean? This standard deviation got to be from what? Got to be from the sample right here. Got to be from the sample. So this 0.0358 is your sample standard deviation. Determine the 95% confidence level for the population mean. Alright, so step 1 out of 2 want me to find the critical value, okay, that will be used to construct the confidence interval. Alright, so I need to find the t-value first. Okay, find the t-value first. So let me go back to my normal curve. Alright, so for my normal curve right now, the whole idea is having my point estimate, okay, which is 0.637, and I'm trying to construct. Eventually, step 2 out of 2 will be constructing a 95% confidence interval. Okay, so how do I find t value? Well, as you know, the 95% is right here in the center. Okay, so that tells me that the area of the two tail outside the 95% confidence interval got to be 0.5. Excuse me, 0.05. Alright, so the area of one tail, doesn't matter if it's the one on the left or on the right, area of one tail is going to be 0.025. Okay, so I can do the inverse t, tapping area to the left. So if I tap in the area to the left, okay, it's going to give me my negative t value, 0.025, comma. Here's a tricky part. What's my degree of freedom? What is my degree of freedom? So since right now we are constructing a confidence interval, is not, this problem is not just about finding the t value, okay? This problem is about finding the confidence interval. We got to find the t value ahead of time. So we got to use that n-1 degree of freedom. So the degree of freedom got to be 21. Okay, got to be 21, not 22. And let's see what that will give me. Alright, second distribute, number 4, 0.025, comma, degree of freedom is 21. So that'll give me about negative 2.080, 3 decimal place. Alright, be careful, okay? Alright, so let's construct a confidence interval. So to construct a confidence interval, my point estimate, okay, I'm gonna write out the things we need to type in, okay? The point estimate is gonna be the 0.637, the simple standard deviation, okay, 0.0358, all right, the sea level, 0.95. Alright, so we go back to stat, test. This time we don't do z interval because my critical value is a t value, so we will do number 8, t interval. Okay, my sample mean 0.637, enter. Sample standard deviation 0.0358, enter. My sample size was 22, enter. My sea level is 0.95. Calculate. Alright. So round 3 decimal places. So that will be 0.621 to 0.653. So my lower bound or lower endpoint, 0.621. My upper endpoint or upper bound, 0.653. Alright, so this one is 0.621, this one is 0.653. So we are 95% confident that the true mean, okay, of magnesium concentration is going to be between 0.621 to 0.653. Alright, based on the simple. Remember now, this is always based on the simple, okay, the simple mean, the point estimate that we obtain, okay. Alright, now I'm gonna flip back to one page here. Alright. If I want to do that by hand, Okay, if I want to do that same problem by hand, I'm gonna go ahead and type it into the calculator. Okay. Remember my point estimate was 0.637, right? Minus my t value was 2.080 times parenthesis my simple standard deviation was 0.0358 divided by second square root of my simple 22, right? Okay, so this is my lower point, what, 621, just like the answer I got earlier. Okay, and the reason why I'm showing you this is because if I would use the degree of freedom earlier as 22, it will throw my answer off slightly. Okay, so for the step 1 out of 1, what's the actual critical value? Is going to be what, 2.080. They only want the positive ones. Okay, like the one you get from the table. Area of two tails, 0.05. Degree of freedom, go down, let's look down here in the center. Degree of freedom 21 is 2.080. Okay, so that was the answer we obtained. Alright, so you can do this problem by hand or use the calculator to do it. Either way will work. Alright, let's look at another one. Okay, same thing. This problem does not ask you to find the t value. Okay, so we're just going to go straight into the calculator. A student records the repair cost of 6 randomly selected stereo, a sample mean of $65.62, and a standard deviation. So right away you can see that this was sample mean and the sample standard deviation. So my point estimate, okay, $65.62, and my sample standard deviation is $24.23. Find the 90% confidence interval for the mean repair cost for stereo. See right here, assuming population is approximately normal. The reason why they make that statement because my sample size is actually less than 30. So they have to tell me it's gonna be, eventually it's gonna be what, approximately normal. Alright, so let's go back. Step test, choosing our t interval. Watch this, okay? I'm gonna do this thing wrong. If I would pick the wrong interval, the first thing I do, the standard deviation, which is 24.23. Okay, mean 65.62. Enter. Sample size is 6. Enter. 0.9 is my confidence level. If I choose the wrong thing, if I choose the wrong interval, okay, so the z interval will be this answer. So this is going to be between, so my lower bound is going to be about $49.35 to $81.89. Okay, that's the wrong one. Because I actually do not know my population standard deviation. I only know my sample standard deviation. So if I choose the correct one, stat test number 8, t interval. Okay, 65.62 is my point estimate. Sample standard deviation 24.23. Okay, enter. The correct answer is actually only from $45.69. Okay, for your lower bound to $85.55. Okay. There's a difference. There is a slight difference when we choose the correct one, correct interval to compute. Okay, so be careful you got to decipher that these problems gonna sound very much alike between the z and the t, but you got to watch out for that word simple mean and the what standard deviation. If I go back to 8.1 notes, okay, assuming the population standard deviation. So those type of problem tells you the population standard deviation. Okay, the 8.3 will be saying what simple standard deviation instead. Okay. All right. The next example is where we gotta type in the raw data. Okay. So using the data, this problem is about test preparation to help the student improve their LSAT exams. Okay. A mock exam is given at the beginning and the end of the course, determine the effectiveness of the course. The following measurement are the net change of the 6 students. Use this data, construct a 90% confidence interval. Alright, assuming it's going to be approximately normal. So this is the whole entire problem, what it's trying to say. They develop into different parts. Compute the sample mean. Alright, so tell you what though. We can find a lot of these answers. Okay, we can find a lot of these answers just by typing this into the calculator. So entering the raw data, you got to go to stat, edit, enter our raw data first. 1, 14, 16, 14, 14, and the 3. Okay, then we're gonna go back to stat, highlight test. Okay, this is a sample. This is a sample of 6 students, so we got to use the t interval. Okay, you do the t interval, and I just put number. I just type enter in my data. So we highlight the word data, press enter. All right, our list was on the L1, frequency 1 at a time. I need to calculate a 90% confidence interval. So when we calculate, it provides my lower bound, upper bound, my point estimate, and my standard deviation right away. So what's my sample mean? 10.3, 1 decimal place. All right, calculate a sample standard deviation. Round the answer to 1 decimal place, 6.5. My sample standard deviation, 6.5. Alright, find the critical value. Okay, so I gotta do this one by hand. So again, I'm doing a 90% confidence level. So if I'm doing a 90% in the middle, that means the area of my true tail gotta be 0.1. Alright, area of one tail, or the area to the left of one tail, got to be 0.05. So I can do either inverse t, typing area to area for the to the left of my t, comma, degree of freedom. You gotta be very careful. Degree of freedom here gotta be n-1, sample minus 1. So that will be 6 samples minus 1. Degree of freedom is 5. Alright. Or we can just look up on the table. Area of 2 tails. Area of 2 tails. 0.1 is the area of 2 tails. One tail would be 0.05. Go down to degree of freedom 5. 2.015. Okay. So the final answer for this critical value is 2.015. Alright. But when you do the inverse t, that answer is going to be negative because it's referring to the t value on the left side. Alright, my confidence level already show right here. Round to 1 decimal place, so my lower bound will be 5.0. my upper is about 15.7. Okay. All right. So what's happening here with the problem itself is saying these number means the net change. So my net change, my average net change of the student score, okay, the average change between students LSAT score, okay, from the beginning to the end of the course is from what, 5.0 to what, 15.7 differences. Okay. All right. So that's how we find, or that's how we construct the confidence interval using T intervals. All right. Thank you for watching.